Good morning, everyone. Almost noon, and welcome to another of our cosmic conversations here on our Morrison Planetarium Facebook page and going out to OpenSpace YouTube. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences, and I am honored, nay, privileged to be here with Dr. Adrienne Cool. Hi, Dr. Cool.
It is so nice to see you, Josh. Thank you so much for the invitation. I am honored and thrilled to be on Cosmic Conversations with Cal Academy, and you in particular.
So, a little history. I have had the opportunity to learn from Dr. Cool as a student at San Francisco State, and it is super exciting to be able to bring Adrienne on as a presenter to share some of the amazing work that she does. So, with that, let's check out our OpenSpace software, where we are checking out a beautiful model of our own Milky Way galaxy. Now, we're going to start heading in, and as we do, we are heading into a pretty special spot here in our Milky Way galaxy, a bit out from the edge, and in a part we call the disk, we are heading in towards our very own solar system. And on the way in, we are going to go visit a spot that I know is near and dear to my heart, and I hope many of our viewers, as well as Adrienne, we are heading into planet Earth, but specifically a spot on the San Francisco Peninsula we know as San Francisco State, specifically a place in San Francisco State where I know I've spent a lot of time, and that is right up here on the West Coast, Thornton Hall. So, Adrienne, can you tell us a little bit about what you do at San Francisco State?
Sure. So at San Francisco State, I'm in the Department of Physics and Astronomy, and I teach and do research, and I'm also the director of the planetarium and observatory. And one of the really fun things I get to do is work with students like yourself who decide that they want to go on to careers in education of different kinds, informal or formal education. And we're very lucky to have a wonderful planetarium right on campus that serves as a training ground for students who are interested in that. And that's one of the really fun things I get to do at San Francisco State.
Now, if and when we have a ability to go out and be places again, there are still public shows that happen at the Hagar from time to time?
Absolutely, yes. We have public shows Friday lunchtime for those who can get to a lunchtime show, and occasionally on typically Wednesday evenings as well. And then we have free school show, I should say, let me add, so we're talking probably to lots of Bay Area folks here. We offer free shows for school kids. Just contact us, find our website, San Francisco State Planetarium, and you can contact us and arrange a show for school children.
Before we head just a little bit north, I wanted to point out one last thing. There's the observatory right up here on the roof of Thornton Hall, which I got to say is one of my very favorite places on planet Earth. I can put myself there immediately just by imagining it.
That's awesome.
So myself made a trip up 19th Avenue once upon a time from San Francisco State to the Academy, and we are privileged to have such a wonderful astronomy institution so close that many of our presenters at the Cal Academy actually began their trip down astronomy lane at San Francisco State or completed their master's degree there. So from all of us to you and the faculty, a big thank you.
And congratulations to you. It's we love this wonderful connection to California Academy of Sciences, such an amazing institution.
So a lot of your work as an astronomer at San Francisco State and beyond doesn't focus on planet Earth. Can you tell us a little bit about your research background?
Absolutely. So my research is focuses on what we call globular clusters, globe-like balls of stars. The ones I study are the ones that orbit are part of the Milky Way, our own galaxy. Although these clusters exist in every galaxy, really. And I study some of the nearest ones, but this is a wonderful rendition here showing their distribution in our galaxy. There's a long and sort of storied history to globular clusters because they were used first to discover the structure of our galaxy, and it was a realization about 100 years ago now, a little more, that their distribution in space was a sign that we are not at the center of our galaxy, which had previously been thought. And so what you find as you look around, and I see you're giving us the big tour here, is that there's a concentration of them in one direction in space. And it was Harlow Shapley back, like I said, about 100 years ago, who posited that they must be centered on the center of the system in which we reside, which we now know to be the Milky Way galaxy. Yeah, figured out that we're out in the suburbs, which is probably a good thing.
I heard someone give the analogy of if you were wandering through a forest and you saw more trees on one side of you than the other, you would say that the center of the forest is probably in the more trees direction.
Absolutely. It's a natural thing to do. It was nevertheless a really big leap because it required concluding that the Milky Way and the universe at that time was way bigger than anyone had thought. And so even though there's a sort of natural idea about that, it's also it was kind of a hard thing to do nonetheless. And took some doing before people actually really took it up and believed it.
That's wonderful. And apparently the wonderful gifts of globular clusters doesn't end with that. We're still using them for a lot of research, right?
Yeah, globular clusters are kind of, I like to say, the Rosetta Stones of the Milky Way. We can learn so much from them, and we've learned a lot about how stars evolve over time. There are sort of the life histories of stars from them. A lot about the formation of elements from studying globular clusters. My particular orientation is towards the dynamics of star clusters, and it's a really neat problem, right? Like, these are balls of stars. They're orbiting our galaxy. What happens? Is that stable? Can gravity just hold this thing together forever? What happens? How does it work? And is it stable? And so my students at State and I have been studying these for a long time. And the kind of interesting story is, well, broadly speaking, they're quite stable. In fact, stable enough that many of them, not all of them, undoubtedly, but many of them have survived since the very early stages of our galaxy, even before the disk formed. They're more than 10 billion years old, most of these clusters. But they're not completely stable. Stars they lose stars gradually. Stars evaporate off in sort of a gas analogy. And over time, the center parts gradually condense, and the theoretical modeling of this is very, very clear. And so an expectation is that the center parts will get so dense that eventually you might form sort of very massive black holes, like few thousand solar mass black holes in the centers. And in fact, people have been looking for those, and there are hints, but nothing really rock solid at this point that they may be there. Our own research, my group's research, is about binary stars, pairs of stars that orbit each other, tight binary. And why? What does that have to do with the story? Well, these things act like little egg beaters in the middle of the cluster, and they keep things stirred up. And things can't sink to the center as easily if things are continually being stirred up. And so understanding the binary star populations in globular clusters is an important part of understanding their long-term evolution and sort of survival. And so that's part of why, that's a lot of why we've been studying them. And I'll just throw out one other kind of cool thing, because there's so many interconnections in astronomy that are so fun and interesting. And one is that many of your listeners may have heard undoubtedly about the discovery of gravitational waves in the last few years. It's been a huge leap forward in our capacity to look at the universe and study it. And what's been seen, right, are merging black holes, very massive black holes, like 20, 30, 40 solar mass black holes merging. Well, pairs of them. So where do those come from? Well, cool connection. One of the ways, they're not so easy to make. You have to have two big explosions before a pair of black holes form. So that's not easy to necessarily maintain, keep the binary intact. In a globular cluster, they kind of form quite naturally. Early in the evolution of the cluster, a few black holes will form. They're massive. They will tend to kind of disrupt other binary stars and take the place, we call these exchange collisions, take the place of another star and wind up in binaries naturally. And then sometimes they go flying out for reasons we don't have to go into, but so those could be that could actually be the origin of these massive black holes. So crazy, fun, interesting connections.
So Ryan's jumping in to ask us about blue stragglers. And we do see in this image, I believe is a Hubble telescope image that you were
Yes,
involved
it
with.
is. It's a mosaic of several Hubble telescope images of the biggest, baddest cluster in the galaxy. It's called Omega Centauri. You can actually see this naked eye if you're like in Tucson, southern U.S. or
Not
anywhere
in
in
San
the southern
Francisco.
hemisphere. Not from here, just sort of on the horizon. But it is a naked eye object, and it actually is. It's so large, something like 3 million solar masses worth of stars.
Wow.
It may actually be the core of a former galaxy that got gobbled up by the Milky Way. Nevertheless, we call it a globular cluster, along with the other 150 or so in the galaxy. And yeah, blue stragglers, very interesting story. It's not at all uncommon to see in globular clusters stars that should have already burned out, but are still there. And so what is that about? And in some clusters in particular, and you see several of these sort of bright blue stars that are massive enough that they should have burned out, given how old the clusters are. And what we now understand is that they're the results of collisions between stars that have essentially rejuvenated the star, brought more hydrogen up to be fused, and so the star straggles along as a hydrogen burning star for longer than you'd expect because of this kind of merger. And there's been some really good work to show, yeah, these objects really are more massive than normal stars in clusters.
Now, if we're looking at this image and picking out some blue stars, could those be candidates for blue stragglers?
You know, this is actually not what those blue stars are in this cluster. No, there's another one that maybe is possible to show, but this one, the blue stars are actually what we call horizontal branch stars. These are stars that have gone past the stage where they're burning hydrogen. And yeah, this one, in a minute, I'll talk about that. The other one, those are helium-burning stars that are currently manufacturing. Yeah, in this cluster, the blue ones are helium-burning stars that are making carbon and oxygen, new carbon and oxygen for the universe.
I'm a fan.
Yeah. So, but that other one, that if you want to show that one again.
Thank you, Mary.
Yeah, there you go. I don't know if it's possible to zoom in a little, but there are a few blue stars right in the center there. Yeah, there you go. Those not the brightest blue stars. Those are the helium-burning stars, but the slightly fainter blue stars right in the middle. Those are so-called blue stragglers. They're blue. You can see the blueness there. And by stragglers, we mean they're sticking around longer than they should. And masses have been measured for a bunch of those stars, and they really do have significantly larger masses, 2 or 3 times the mass of normal stars in the cluster. Yeah.
That is super cool. Well, Thank you for sharing some of your expertise. But as awesome as that is, that's not what you're here to talk to us about today, right? So
Indeed.
Let's jump back over to OpenSpace for just a second. And quick plug for OpenSpace. If you folks think what we're doing on our software is cool, this is a free and commonly available software. You can download and check it out yourself. OpenSpaceProject.com is the place to go. But with that, we can actually see a little blue planet I know we're all very fond of. Can you tell us about Astronomers for Planet Earth? Why would people who study the whole universe care so much about this one little mud ball?
What a good question. Yeah, so, so let me just say that, as I'm one of many astronomers who've had this on our minds. It had been bothering me for some years, really, that I spend so much time thinking about things that are like impossibly far away, right? Like the nearest clusters that I study, which are the nearest ones to us, are quadrillions of miles away. They're really insanely far away, and they're fascinating, and I love studying them and working with students about them. At the same time, things are happening on Earth that really, really matter, and we don't want to be that person who's daydreaming while the house is on fire. And so what had been on my mind for some time, what I was trying to figure out is, well, what can astronomers do? Of course, we can all do things as individuals, and we do. But is there something that astronomers in particular can do? And it finally dawned on me, and it had dawned on other astronomers earlier. I've been working on this, but it finally dawned on me that, well, yeah, there's actually quite a bit that we can bring to this, the climate crisis, and address the climate crisis as astronomers. And there are several pieces to it, but one is just that we have a perspective that's unusual and special, I think. Who else knows, just how far away all those other planets are? Of course, all the discoveries of planets around other stars are fantastic, and it's given us a perspective on the Earth, that itself, which is really amazing. And we're going to continue to learn for many years now about sort of Earth and how it fits into this larger scheme of planets in the Milky Way. But those planets are really far away. I mean,
Right.
the nearest one, right, 25 trillion miles away. If you ask, what is the fastest spacecraft humans have ever created, and then say, well, suppose we went at that speed to the nearest planets, those may or may not be habitable, right? That's another whole other conversation. But it would take more than 10,000 years at incredible speeds, 165,000 miles an hour, the Juno spacecraft speed. So, we're not going there, right?
No.
And I think that there can be some misconception potentially about that. That may sound odd, but I think there's so much wonderful stuff in the news about it because it is so interesting. We have to be a little careful. So anyway, we have that perspective, but there's more. We're scientists, and the tools that we use are not unrelated to the tools that climate scientists use. So we have some ability to we bring some credentials to that. But also significantly, we have a lot of reach. And I want to just back up for a second and say, what do I mean by astronomers here? Astronomers for Planet Earth is an organization that formed to bring together not just professional astronomers, but folks who have a strong connection in their work or life in general to astronomy. So students of astronomy, professional astronomers, folks who love astronomy and have made it part of their lives, whether or not it's part of their work life, citizen scientists, amateur astronomers, high school teachers who bring astronomy into their curriculum, planetarium folks. So
proud to be a part of it.
All around the world, people who work in science museums. There are a tremendous number of people who have a strong connection to astronomy and who have reach, who teach classes, do planetarium shows, do outreach to school children, do outreach in their community, sidewalk astronomy. One of my favorite things to do is sidewalk astronomy. So we reach literally millions of people every year. And we as much as we're talking about things out there, the things out there give us a perspective on things here, and we can bring that into our conversations. And so that was kind of the motivation and the idea of Astronomers for Planet Earth.
A question some folks might be thinking is, number one, how do I get involved? This sounds like an awesome group. I do sidewalk astronomy. I've decided I want to join Astronomers for Planet Earth. What do I do?
Yeah, great. And so you can join us. You can click the link, join us link, and it'll say a little bit there. And let me just say a little bit about the membership right now. So the organization, I should say, let me just also say a little bit about the creation of the organization, because it's an international organization. A few of us at San Francisco State, some students and faculty got together. A colleague at Yale got together last fall and sort of started it off. And then very soon thereafter, we were contacted after the website launched in October, by a European group who'd been doing a lot of work and thinking the same things. And then we merged with that group. They had been called Green Astronomy. And so we've merged under Astronomers for Planet Earth. And we have regular meetings, international meetings in many different time zones, always interesting. So how many, there are now more than 500 members of this group.
Wow.
Like I said, students of astronomy, planetarium folks, museum folks, high school folks, lots of professional astronomers as well.
I
And
think Mary's got the list stuff if people want to see. It's a pretty impressive monolith of names with some exemplary folks on it.
And so what I'd say is please join us. And so when you join, what the first thing that happens is that you'll become part of a listserv that we have. We have a platform on called Groups.io where we can communicate with one another, because part of the idea of this is to bring us all together to learn from one another. Many astronomers and folks, working in astronomy have been working on this for a lot of, for years. And speaking for myself, I want to learn from them. How do I communicate this? How do I do this best? Sharing ideas, and then going out into the world to take action. And so this Groups.io platform that we have, which is separate from this website but related, is provides a way for us all to communicate with each other, and also it's a repository where we can share slides with each other, we can share materials with each other, we can talk to each other. And so that's the first thing that happens when you become a member, that you become part of that conversation and bring your ideas to, how do we do this? How do we use the astronomical perspective to help in the battle, against climate change?
Well, I think we've got a short video we want to share with you folks with a pretty famous astronomer who very much espoused these ideas. And then I think we'll get to questions. So can you tell us a little bit about video representation?
Yeah, so let me just say that one of the goals of the organization include outreach to the public, and also then support for astronomers to teach each other what's going on. So part of the public outreach piece is that we have a social media presence. Astro, the number 4 Earth is the tag. And one of our members, Jessica Agnos, has been leading an effort to create videos. And this is there are 3 now. 4th is in the works, and this is the first one from that series.
The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. Like it or not, the Earth is where we make our stand. It underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
That's awesome to see. So if folks are interested and they want to catch more similar videos, they can head to Astronomers for Planet Earth and dive in. We did have a couple of questions popping up, and I want to make sure we give folks time to get to them. So if anyone else has questions, please throw them in the chat. But Lara asked, by the time we've reached a point where our planet becomes uninhabitable, won't we be able to just move to another planet since habitable exoplanets are so far away? So if something happens to Earth where we eventually can't live here anymore, won't we simultaneously be at a technological epoch where traveling to another world becomes possible? Oh, we got you muted. There we go.
Thank you for that question. It's a really important one. The issue is this: the rate at which the climate is being affected by human activity right now is fast enough that that the technology that would be required to go to another planet is far, far, far beyond anything that we're going to be able to do in time. So, you know, we already actually know how to solve the climate problem. We have to do it. We need to gather enough people to believe, yes, we're going to do it and do it. It is doable. That's a key point. Unfortunately, I'm not going to say even unfortunately, it just is the case that we cannot solve this by going somewhere else. We're going to learn a lot from studying those planets, but they're really too far away to solve this.
Ooh, tough one coming in for both of us. What are your favorite astronomers, past or present?
Gosh.
That's okay. I'll try this first. It's always a tough one. Past astronomers, I think I'm going to fall into the celebrity astronomy hole and say that I really like Brahe. Not as a person, he seemed like a real jerk, but when you've got your own private astronomy palace on an island, you can have cool parties there, and you've got a metallic nose. You've got a lot of things going for you, and certainly you at least stand out from the crowd.
Yeah, and I'm going to go on that scheme too. Galileo is just, someone, his writings about his discoveries of the moons of Jupiter and, mountains and craters on the moon are some of my, very favorite things. And I'll just say that.
There's a bunch of others, I think, like, have compelling stories. We just had a post on our page about Annie Jump Cannon and someone that doesn't get enough credit.
Oh gosh, I mean, they're just so, yeah. Cecilia Payne-Gaposchkin.
And for more contemporary ones, I'm going to throw Vera Rubin out there. She just got a telescope named after her, and that's the least we can do to pay back one of the amazing voices in astronomy.
Fantastic.
Any other questions come in, feel free to post them. I personally had one that I've been kicking around for a little bit. If you have a really big globular cluster versus a very small dwarf galaxy, what's the cutoff? What makes one one and the other the other?
Yeah, great question. There isn't any really sharp cutoff there. And it's actually very, very interesting to study the sort of in-between places, and there's a lot of work on that these days. The one broad distinction is, galaxies often have dark matter in them. Mm-hmm. That stuff that we know is there because otherwise the thing would fly apart. There's got to be extra things pulling the stars together. For globular clusters, that's not the case. We don't see any signs that there's dark matter. We can explain how they work just from the stars that are there. Nevertheless, there's room between globular clusters and galaxies, and I think I even mentioned that. And there are things that occupy that space. Not a lot, but not. I won't even say that. There are things that occupy that space. And like I said, even Omega Cent itself, even a thing that we call a globular cluster in our galaxy, that biggest one in the whole Milky Way, that may be the remnant actually of a galaxy, the core of a galaxy that was stripped of other stars as it came through the Milky Way.
My dog's trying to ask a question too, but I'm going to try and power through. We have a question from Sergio. Chances of being hit like when the dinosaurs got hit by a meteor. As astronomers for planet Earth, we also have some of that idea of preserving the planet from threats outside of our planet too.
Yeah, I mean, the work that's been done on near-Earth objects and asteroids to monitor what's out there and just develop the awareness of things that could potentially threaten Earth, I think it's been a really important contribution from astronomers to the protection of the Earth. Fortunately, there's no sign at the moment that anything is, is threatening the Earth in that way at the moment. But there's a time scale issue there that I think the caller is asking about. And again, the time scale of that is such that the climate, the most urgent thing is still definitely the climate and our impact on the climate. And fortunately, like I said, we can fix this. It is doable. We know how, but it takes a lot of work on the part of many, many people in all different things. It's an all hands on deck kind of situation, and that's why, we as astronomers are putting our hands in, and people in all different, lines of work and things, and organizations like Cal Academy and many organizations doing so much important and good work on this. It's the all hands on deck kind of situation. The climate crisis is the urgent one. But thank you for asking. The other is important to know about,
No one wants to get hit by an asteroid, but
No.
I'd rather have a livable planet too. So
Yeah.
we are very proud to put our shoulder behind the wheel alongside you, but this is a very important message to share. Thank you, Adrian, for joining us here. This has been a delight.
Thank you so much for having me. It was great to be here.
We had a question or a comment pop up from my boss, Ryan Wyatt, about his favorite astronomer, Jackie Faraday, and Kepler historically. If you're a fan of Jackie Faraday, one of her students is a mutual acquaintance of myself and Adrian, will be our our Cosmic Conversation speaker in just 2 weeks. So if you want to hear from the newly minted Dr. Eileen Gonzalez, tune in then. If you have more questions about near-Earth objects and the weird little bits of our solar system, check out next week when we have Frank Marshy, who is an expert in such things. Tune in. Meteor and asteroid questions would be most welcome for him. From myself, if you have an opportunity, check out, download, and play around with OpenSpace. Let us know what you think. We've got a survey that we would love for you to fill out if you've been watching our programs of late. It's letting NASA and the American Museum of Natural History know what your familiarity is with the OpenSpace software. Check it out, fill it out. We really appreciate it. And Adrian, is there any final message, anything you'd like to share with our audience?
No, just that thank you for listening, and please check out the website. It's astronomersforplanet.earth. It's a .earth website. We did that on purpose. And we want your voice in our organization if you're interested.
Well, thank you all for tuning in, no matter where you are tuning in from here on planet Earth. We really appreciate your eyeballs and attention. And if you like the message, please share it out with the rest of your networks. From all of us at Morrison Planetarium, and I'm going to throw San Francisco State in there too, thank you for joining us. Stay home, stay happy, stay healthy, and we hope to see you all again soon.